In this section, we'll decide whether a given function can be classified as an even function, an odd function, or maybe it's neither. So the questions in this section, you'll be asked, is the function even, odd, or neither? Okay. So first, let's look at an example of an even function just to see what this looks like. Then we'll see an example of an odd function, and then we'll pull it together and answer this overall question. So for even functions, an even function, we know it's even algebraically if we can show that f of negative x equals f of x. And if we're looking at the actual graph of an even function, the graph of every even function has what's called y-axis symmetry. So spot checking, this means if you have a point xy, you're going to have a matching corresponding point negative xy. All right, so over on the left here, graphically, if we look at the graph of this function, f of x equals x squared plus 1, we've got this upward facing parabola. So first we can see that this graph has y-axis symmetry, meaning if you folded the graph in half along that y-axis, you'd have a perfect match from left to right. And if you want to spot check, for example, if you see the point 2, 5 here, you have the matching point negative 2, 5. You have the point 1, 2 with the matching point negative 1, 2. So you have that match of the positive and the negative x across that y-axis. So because you have y-axis symmetry, you know visually this is an even function. Okay. But typically on test day, I'm going to be asking you guys to show me algebraically whether you have a function that's even, odd, or neither. So I really want to focus more on the algebra, so showing the algebra. And when you guys are in the homework, it's just going to be, multiple choice. Is the function even, odd, or neither? But on test day, I want to see this work here in the box. Okay. So to show that this is an even function, first I'm going to find f of negative x. I'm going to find f of negative x. So to find f of negative x, I'm going to take my f of x function, right? And before, anything that was happening to x, f of x equals x squared plus 1. Anything that happened to x will now happen to negative x, right? Because now we're finding f of negative x. So this will be negative x in parentheses squared plus 1. And if we take a negative value and we raise it to an even power like 2, 4, 6, that negative value comes out positive. So we have the x squared and it's going to be positive. So we end up with x squared plus 1. So f of negative x equals x squared plus 1. And if we compare that to the original function, I can see that f of x equals x squared plus 1 and f of negative x equals x squared plus 1. So I started with f of negative x. I evaluated, I simplified, I got x squared plus 1, and I know that this is equal to f of x. So I have that connection, f of negative x ultimately equals f of x. So here's my summary statement, f of negative x equals f of x, so the function is even. Even if you can do a lot of this in your head, even if you think it's obvious, I want you guys to prove to me that you know what you're doing here. I want to see this f of negative x step. I want to see you plugging negative x into your function, simplifying, and then writing this summary statement at the end. So make sure you give me this line. Okay. All right, so next up, let's look at an example of an odd function. So f of x is an odd function if f of negative x equals negative f of x. The graph of every odd function has what's called origin symmetry. And you can spot check this by looking at the point xy. Every xy should have a matching negative x, negative y. That's origin symmetry. So first, let's take a look at our graph just to see an example of origin symmetry. And we're looking at this function f of x equals x cubed. So on our graph, this is what origin symmetry looks like. And if you want to spot check, we have, for example, the point 1, 1. Then we see that we have the matching point negative 1, negative 1. If we went way up here, it's off the graph, but you would also see the point 2, 8. And then if you go way down here, you would also see the matching point negative 2, negative 8, right? So this is what origin symmetry looks like. The xy point with the matching negative x, negative y across the origin. All right, but primarily what I'm going to ask you guys to do is show me algebraically. Show me algebraically that you've got an odd function. So the first step is you find f of negative x. And that's going to be the first step for all of these. We always start by finding f of negative x, right? We did it for our even function. We did it for our odd function. You start by finding f of negative x. You simplify it and you see what you're looking at. So in this case, we're going to take what used to be our x, and we would take that x and cube it. Now we're going to take negative x in parentheses and cube it. And if I take a negative and raise it to an odd power, like a 1, 3, 5, 7, that's going to stay negative, right? So we end up with negative x cubed. Now if I compare this negative x cubed, right? F of negative x equals negative x cubed. F of x equals positive x cubed. So I don't have a match, right? F of negative x doesn't equal my original function, right? My original function was x cubed. I got negative x cubed, so I know my f of negative x doesn't equal f of x. If it had equaled f of x, I'd have an even function, right? So I can tell from this already, I don't have an even function. Okay? So no even function. But I still could possibly have an odd function. So now what I want to do is find negative f of x to see if that gives me a match to f of negative x. So that's what I'm doing down here. So up here, I find f of negative x, and then down here, I find negative f of x. So negative f of x equals negative x cubed. And then we can just remove the parentheses, and that ultimately gives me negative x cubed. So connecting what I started with and what I ended with, because f of negative x equals negative x cubed, and because negative f of x equals negative x cubed, I can say that f of negative x equals negative f of x. Those are the same things. So the function is odd. So that's my summary statement. Okay, and I can kind of check it and confirm it graphically. I can see that I have that origin symmetry. So because I see graphically that I have that origin symmetry, that's further confirmation that I have an odd function. But I'm going to ask to see the algebra on the test. All right, so let's take a look at number 10. It says determine algebraically and graphically whether each function is even, odd, or neither. I'm going to show my algebraic work. Algebraically will be over here. So I'm going to start with that. So number 10, f of x equals 2x to the fourth plus 5x squared. First, I'm going to find f of negative x. Okay, so f of negative x is going to equal 2 times negative x to the fourth plus 5 times negative x squared. So that's my first move, rewriting negative x in parentheses everywhere that x used to be. And then negative x in parentheses raised to the fourth power raised to an even power is going to come out positive. So this term, okay, so this term will come out to be positive 2x to the fourth. Okay. My negative x in parentheses squared will come out positive x squared. So this will simplify to positive 5x squared. So just to recap what just happened, we took f of negative x, which is 2 times negative x in parentheses raised to the fourth power, plus 5 times negative x in parentheses raised to the power 2. And we ended up with 2x to the fourth plus 5x squared. If I look at my original function, I know that f of x equals 2x to the fourth plus 5x squared. I just showed that f of negative x equals 2x to the fourth plus 5x squared. So now I can connect the two. So I know that f of negative x equals 2x to the fourth plus 5x squared, which is the same thing as f of x. Okay, so here's my summary statement. I evaluated f of negative x. I showed that it equals f of x. So I have an even function. Okay, and these are the steps that I'm following over here to the right. Step 1, find f of negative x. Step 2, see what f of negative x equals. And in this case, this first iteration was true, right? F of negative x equaled f of x, so I had an even function. All right. If we want to look graphically, if I go to y equals on my graphing calculator, oops, turn these plots off, 2x raised to the fourth power plus 5x squared. So if I look at my graph, it looks like a really tight, skinny parabola. And just as a check, if I use trace and enter x equals 1, I get y equals 7. If I enter x equals -1, I also get y equals 7. So I see that I've got that y-axis symmetry. And you could, of course, check this for a few more points. But I have that y-axis symmetry on my graph. So that confirms that I have an, even function. Even function. Okay. Let's take a look at number 11. So I've got f of x equals x cubed minus 4x. I want to figure out algebraically whether my function is even, odd, or neither. So my first step is I'm going to find f of negative x. So f of negative x for this function is negative x in parentheses raised to the third power minus 4 times negative x. Negative x raised to an odd power like 3 stays negative, so I end up with negative x cubed. And then negative 4 times negative x gives me plus 4x. Okay. Now I just got negative x cubed plus 4x. F of x equals positive x cubed minus 4x, so I definitely don't have a match, right? Before, when I found f of negative x for number 10, it was the exact same thing as what I started with. That was my f of x function, and I was done. I definitely don't have f of x, right? So my function is not even. So my function is not even. And you don't have to write this out on the test, but I just want to spell that out. I definitely don't have an even function. So now I know I don't have an even function. Maybe I have an odd function. So to figure out if I have an odd function, now I'm going to take f of x, but I want to take negative f of x and see what that equals. So negative f of x would be the negative of my original function, so the negative of x cubed minus 4x. And if I distribute that negative sign, this gives me negative x cubed plus 4x. And now I have a match, right? Negative x cubed plus 4x, negative x cubed plus 4x. I just showed that f of negative x equals negative f of x. So I'm going to write my summary statement. I just showed that f of negative x equals negative f of x. So I have an odd function. Okay. So that was the second case. F of negative x didn't equal f of x, but I did get a match here. F of negative x equaled negative f of x, so I knew I had an odd function. And if we look at the graph of this, we've got x raised to the third power. Let me clear this out. So y equals x raised to the third power. Can't type today. X raised, there we go, to the third power, minus 4x. So if we look at our graph, we can see those matches across the origin. So for example, if I use trace and enter x equals 1, I have y equals -3. So because I have 1, negative 3. I should have a matching negative 1, positive 3. So if I type in negative 1, there's my positive 3. If I type in x equals 2, I have a 2, 0. That means I should have a matching negative 2, 0. Let's test it and see if I do. And I do, negative 2, 0. I can do it with my 3's, 3, 15, negative 3, negative 15. So I can see that I have origin symmetry. So this is just kind of a graphical check, a confirmation that I do have an odd function. Okay, I'll erase this part over here. So this is what your work should look like. All right, so let's check number 12. So we want to know if number 12 is an even, odd, or neither function. So first I'm going to evaluate f of negative x, and this would be negative x to the 4th power plus 3 times negative x to the 3rd power minus negative x plus 1. And I'll start simplifying this. So negative x in parentheses to the 4th power will be positive x to the 4th. Negative x in parentheses to the 3rd power, an odd power, would stay negative. So this would be minus 3x cubed. Minus negative x would be plus x. And then I carried on my plus 1. All right, so let's see what we've got. Because we took f of negative x. Instead of x to the 4th, we had negative x to the 4th. Instead of plus 3x cubed, we have plus 3 times negative x cubed. Instead of minus x, we have minus negative x, and then our plus 1. We simplified. We got x to the 4th minus 3x cubed plus x plus 1. So first, does this equal f of x? I have x to the 4th, that's good. But then right there, I have plus 3x cubed versus minus 3x cubed. So I don't have a match with f of x. I don't have a match with f of x. Okay. Let's find negative f of x. Maybe that will be a match. I know I don't have an even function, right? I don't have an even function because f of negative x didn't equal f of x. Let's try negative f of x. So negative f of x is going to equal the negative of, let me erase that, the negative of x to the 4th plus 3x cubed minus x plus 1. I'm going to put a negative sign out in front of that and distribute. So this will give me negative x to the 4th minus 3x cubed plus x and minus 1. So when I found f of negative x, I got x to the 4th. When I found negative f of x, I had negative x to the 4th. So right there, I don't have a match. Okay, so f of negative x doesn't equal f of x, which means I don't have an even function. F of negative x also doesn't equal negative f of x, which means I also don't have an odd function. Okay, those are my two possibilities. So if I want to write my summary line here, f of negative x does not equal f of x, and f of negative x does not equal negative f of x. So the function is neither. It's neither even nor odd. So this is the case where our function is neither. And that's this third bullet here, right? So f of negative x doesn't equal f of x, and f of negative x doesn't equal negative f of x. So we have the case where it's neither. And if we look at the graph, let's see, y equals x to the 4th plus 3x, x to the 4th plus 3x cubed minus x and plus 1. And there's no symmetry there, right? There's no origin symmetry. There's no y-axis symmetry. So I don't see either kind of symmetry. So I have a function that's neither even nor odd.